All right, so today we're going to be talking about Chapter 6, Section 2, which is what we refer to as substitution. Another word for substitution that a lot of people don't realize is the word replacement, which is exactly what we're going to be doing. So let's look at this problem. Let's say that we have y is equal to 2x plus 1, and we also have that 3x plus y equals negative 9. So I've got these two different equations and I'm trying to figure out what the solution is, meaning where do these two lines intersect? So if I were to graph these two lines, my answer or my solution would be where they intersect. And I'm going to use the method of substitution to determine that. So substitution means this. If you notice, we have that y equals and then we have 2x plus 1. So since those are equivalent, what I can do is I can substitute 2x plus 1 everywhere that there's a y in my second equation. And what that looks like is 3x plus my new y is going to be 2x plus 1, and then I'm going to have equal to negative 9. From here, I can combine like terms. 3x plus 2x gives me 5x. Bring down my 1, keep it equal to negative 9, and this is a multi-step equation where now I can solve for x. So we would subtract 1 from both sides to get 5x equals negative 10, and then divide both sides by 5. So I get x is equal to negative 2. But I'm not done there. This is just part 1 of my final answer. What I know is that since this is an intersection, this is going to be a coordinate pair, x comma y. This is only one part of my final answer. So now what I need to do is I need to substitute this back into one of my original equations anywhere I see an x. So I'm going to go ahead and I'm going to substitute in for this first equation. So I'm going to say y is equal to 2x plus 1, and I've just recently found out that my x is equal to negative 2. So I've got y equals 2, and where there was an x, I'm going to replace it with negative 2. Now if you'll notice, what I can do here is I can solve for my y variable by multiplying out this right side. So I get y is equal to negative 4 plus 1, and negative 4 plus 1 should be negative 3. This is going to be part 2 of my solution. So, because I know that my coordinates are an x, y, then my final answer should be my x value, which we said was negative 2, and my y value, which we said was negative 3, and this is going to be my solution where these two lines intersect. However, I want to check myself. So, check yourself. Boom. All right, here's how we're going to do that. We're going to take these two equations and we're going to rewrite them at the bottom of our paper. So, I had y equals 2x plus 1 as one of my equations, and my other equation was 3x plus y equals negative 9. Now what I'm going to do is I'm going to take my solutions, negative 2 and negative 3, and substitute them in for y and x in each of these problems. So I'm leaving some space. This should be a 3x. So I should have 3 plus, and now what I'm going to do is I'm going to substitute. My y value is negative 3, and my x value is negative 2. Same thing on this side. My x value was negative 2. My y value was negative 3. And then I'm going to check. So I get negative 3 equals negative 4, because 2 times negative 2 is negative 4 plus 1. And we can clearly see that negative 3 is equal to negative 3. Now over here we have 3 times negative 2 is negative 6 plus negative 3 equals negative 9. And again, we have that negative 9 equals negative 9. Therefore, this answer is correct. Boom. We did it. And that is how you use substitution to solve systems of equations.